All right, so we are now on determining recursive and explicit expressions day 2. So last time we were day 1, now we're day 2. And if you're wondering why in the world there's a big white rectangle blocking everything, it's because I tried recording this 3 times on my iPad and it didn't work. And instead of erasing everything and writing it again for the 3rd time, I decided to record it on Zoom instead of my iPad and just block out my text and show you a little bit one by one because I am so tired of rewriting everything. Okay, so let's start off with our explicit formula. Explicit formula definition. It's a formula that's used to calculate the nth term of a sequence using the term's position in the sequence. So you're going to calculate the nth term of the sequence using the term's position in the sequence, using the n value. Whereas last time, we used the previous term to calculate the next term. So it's a little bit different, but it's just another formula that we can use to solve for the nth term of a sequence. So you guys can have as much time as you want to write this down. Pause it now. Okay, so I'm going to assume you're done because you have the ability to pause. So I'm going to, oh, that is weird. I'm going to go like this. Okay, so I'm going to show you guys the explicit formulas for arithmetic and geometric sequences. So you can copy it down over here. Remember that a sub n stands for the nth term, and that a sub 1, well, if it has a 1 next to it, that means it's the first term, okay? Remember the little number next to the a or the g represents the first term. Then we have plus the common difference multiplied to n minus 1, where n is your term number. For the geometric sequence, you have g sub n, representing your nth term, equals g sub 1, which is your first term, multiplied by r, the common ratio, to the power of n minus 1 in the tiny upper right-hand corner. So the n minus 1 is all part of the exponent. And n, once again, is your term number. Okay, so you can pause it. You can pause it and write it, take however long you need. I'm going to move on now. Oh my gosh, that looks so weird. Okay, so we're going to write an explicit formula for each arithmetic sequence, then use the formula to determine the unknown term. So take a look at number 1. We're just going to do number 1 first, and I'll just show you step by step what happened, or I'll guide you through it. Number 1 says determine the 40th term of the sequence. So if we're asking for the 40th term, then n is 40. That's why I circled the word 40th, and I wrote n is 40. Okay? Now let's go down to the next thing. Over here, I'm actually just going to draw on it. Right here, I wrote down our formula for the arithmetic sequence because they did tell us that these are all arithmetic sequences. So we're only using the arithmetic sequence formula here. So a sub n is equal to a sub 1 plus d times n minus 1. Oops. Okay, you know what? I'm just going to go like that. Just show you the whole thing. Might as well. Okay, and then over in the second step, I plugged in 40 for n because we are looking for the 40th term. Okay, and then in the next step, I replaced a sub 1 with negative 2 because that is your first term. So a sub 1 is your first term, so I replaced it with the first term, which was negative 2. Then we also have the common difference over here, which I replaced with negative 7. How did I know the common difference was negative 7? Well, if you take two numbers that are right next to each other, for example, the negative 9 and the negative 2, you subtract them, as I've done on this step. You subtract those two numbers, and then you'll get negative 7 as your common difference. So that was the result we achieved over here. And so we put it into our formula. The negative 7 appears in the formula now. Then simplifying everything, we have a sub 40 is equal to negative 2 minus 7 times 39. How do we get 39? Well, 40 minus 1 is 39. So I replaced the 40 minus 1 with 39. Now, according to PEMDAS, you have to multiply before you subtract. So that's why in the next step, I multiplied the 7 and the 39 to get 273. That's how I got 273 over here. So we have negative 2 minus 273. Then finally, you do negative 2 minus 273, and you get negative 275 as your answer. Okay? So I know that was fast, but you can always pause and write. So that's up to you to pause and write as much as you need. Let's do the next one. Let me take away this giant box over here. Okay. So for the next one, we wanted to determine the 30th term of the sequence. So for the 30th term, we get n is equal to 30, because the n value is the term number. I also did write the common difference out. So I chose the first two numbers, 125 and 143, and over here I just subtracted them second minus first. 143 minus 125, and you get 18, which is our common difference. Next, we have our explicit formula for the arithmetic sequence. Then I start plugging it in. The n is 30, so I replace it with 30 because we are looking for the 30th term. And I also replaced it here. Okay, and so a sub 30 is equal to the first term. I took the first term, which is 125, and I replaced the a1, which is the first term, with 125. And then for the letter D, the common difference, we said that was 18, so I put 18 over here. And once again, we still have the 30 minus 1. We calculate the 30 minus 1, and we get 29. Oops. We calculate that, we get 29. Then according to PEMDAS, remember you must multiply before you add. So I multiplied the 18 and the 29 to get 522. Then you add them together and you get 647. Okay, so I know that was a lot faster, but I know you guys can pause anytime, so I'm not worried about that. You guys can always just replay it if you were extra confused. And if you replay it and you still have questions, please ask me for help by calling the Get Help button, okay? Or call me over, whatever that button's called. You know what it is. Okay, so let me know, otherwise I'll have no way of helping you, but I really want to. I want to make sure you guys feel okay about this. So let me know, and I'll talk to you later.